In this problem, we're looking at the experiments of Gregor Mendel, and he says that 3/4 of the offspring were observed to have red flowers and a quarter had white flowers, and he found out that if there was one dominant allele, dominant red color allele, that was a capital R, then the offspring was going to have red flowers. Otherwise, if they were both recessive white color alleles, then that was the only condition under which they were both white. What we want to know in part A is, what is the probability that an offspring has one red allele, or one recessive allele, given that the offspring has red flowers? Okay, well, first of all, we need to know how many of them have red flowers. 1, 2, 3 have red flowers. Out of those, how many have a recessive allele? Well, this one does, and this one does. So 2 out of the 3 have a recessive allele, yet still have the dominant color of red. Letter B says, what is the probability that an offspring has one dominant allele, a capital R, given that the offspring has white flowers? Well, the only time that will have white flowers is if they're 2 recessive alleles, and that's only one possibility. Well, of that one possibility, there aren't any dominant alleles. So there are 0 out of the 1, which means there's a 0% chance, which makes sense because we know that if any of them have a capital R, that necessarily makes it red. In letter C, what is the probability that an offspring has white flowers given that it has one recessive allele? Well, one recessive allele is in 2 possibilities, 1, 2. Given that it has one recessive, okay, and then the number of those 2 that have a white color are 0, because to have one recessive allele, that means you have one dominant allele, and if you have one dominant allele, that definitely makes sure that the outcome is red flowers. So there's a 0% chance of that. In letter D, what is the probability that an offspring has white flowers given that it has one dominant allele? Well, this is almost the same thing, except in this case the number that have a one dominant allele is 2, so we're looking for the capital R's. This guy has 2 capital R's, so that's not what we're talking about. We're saying it has one dominant allele, and of those, 0 of them have white flowers, because if you have a dominant allele, then that guarantees that you're going to have red flowers. And letter E, what is the probability that an offspring has red flowers given that it has one dominant allele? Well, we shouldn't really have to think about this really, because if it has a dominant allele, it's guaranteed it's going to have red flowers. Alternatively, if you wanted to actually go and count this, the number that have the dominant allele is 1, 2, 3, and of those, the number that have red flowers is 3, so you get 100%.